Welcome to the fifth hole of the miniature golf course. We're going to begin by copying some vocab. If you need to pause the video, please feel free to pause it. I'm going to go ahead and keep moving forward to keep the file size down. When we are naming polygons, we name them by the number of sides or vertices that they have. Triangle is a three-sided polygon. Tri meaning three. Quad is four-sided. Pentagon is 5. Hexagon is 6. A heptagon is much less common. It is 7-sided. Octagon is 8. Nonagon 9. Decagon 10. Hendeca is 11. And dodeca is 12. Of these, the triangle, quadrilateral, pentagon, hexagon, octagon, and decagon are your most common shapes, most common polygons. When looking at polygons and trying to determine if they are regular or irregular, regular means that all sides are congruent and all angles are congruent. Irregular means that either none of the sides are congruent or less than all of the sides are congruent, or that there's at least one angle that's different than the other angles. If we look at the examples below, here we have 1, 2, 3, 4, 5 sides, so we're talking about a pentagon. The individual tick mark on each side means that each side is congruent to the other sides, and you can see that each angle is 72 degrees. So this is what we would call a regular pentagon. When we study our picture here, we have 1, 2, 3, 4, 5, 6 sides, so we're talking about a hexagon. And we can see that each of the 6 sides are congruent, so we would say that this is a regular hexagon. And in our example here, we have 1, 2, 3, 4, 5, 6 sides, so we're still talking about a hexagon, but it's very apparent that this side here is longer than the other sides, and it looks like some of these other sides are shorter. This is an irregular hexagon. Some more vocabulary. Again, pause it if you need. When we look at quadrilaterals, we're going to draw a flow chart that shows quadrilaterals. And again, quadrilaterals have 4 sides. And the prefix quad means 4. And for this flow chart, we're going to focus on regular quadrilaterals. And the first question we should ask ourselves is, are all sides parallel to each other, or are there 2 pairs of parallel sides, or just 1 pair of parallel sides? If there's 2 pairs, we have something called a parallelogram. If only one side is parallel, or 1 pair of parallel sides, sorry, we have a trapezoid. For the parallelogram, with 2 pairs of parallel sides, we have to ask, do we have all sides congruent? If all sides are congruent and opposite sides are parallel, we have a rhombus. The second question is, do we have 4 90-degree angles? So if we have 2 pairs of parallel sides with 90-degree angles, 4 90-degree angles, we have a rectangle. And if we have a shape that has 4 congruent sides and 4 right angles, we are talking about a square. So when it comes to quadrilaterals, our first question is, how many pairs of parallel sides? 2 pairs or 1 pair? And if we have 2 pairs, are all the sides congruent? Are all the angles congruent, being 90 degrees? And if the question to both of those, or the answer to both of those questions would be yes, then we'd be talking about a square. When you look at this flow chart, you can see that every square is a rhombus going this direction, but not every rhombus is a square, so that doesn't work. Every square is a rectangle, but not every rectangle is a square. Every rhombus is a parallelogram, but not every parallelogram is a rhombus. Every rectangle is a parallelogram, but not every rectangle is every parallelogram is a rectangle. So you can see that in this flowchart that we've created, it always works going from the bottom up, and going from the top down, it may work, but it doesn't work all the time. Drawing quadrilaterals. I've given you different parameters to draw quadrilaterals, special types of quadrilaterals. If we're looking at a parallelogram that's not a rectangle or a rhombus. So a parallelogram is telling us that we have two pairs of parallel sides, but we do not have right angles, and the two pairs of parallel sides are not all congruent to each other. An example would be something like this, where this side is parallel to this side is parallel to this side. However, no 90-degree angles, and this side would be different lengths. In this parallelogram, though, we can see that this angle is congruent to the opposite angle, and this angle is congruent to its opposite angle. A rhombus that is not a square is telling us that we have four sides that are congruent, but we do not have right angles. That's congruent to that, it's congruent to that, it's congruent to that. This angle is congruent to this angle, and again, these opposite angles are congruent here. A trapezoid with a pair of opposite sides congruent. So a trapezoid means that it's got one pair of parallel sides, but we need opposite sides congruent. This one's a little more difficult. It would look something like that, where this side is actually congruent to this side, and they would be opposite sides. A square that is not a rhombus. A square means four congruent sides and four right angles. If it's not a rhombus, that means it doesn't have four congruent sides, so this last example is actually impossible. The last thing we're going to look at today, congruent polygons. For two polygons to be considered congruent, it's pretty much common sense, but the corresponding sides must be congruent, and the corresponding angles must be congruent. So for two polygons to be exactly the same, they must have the same side lengths and same angle measures. You are now ready to get online and print off the fifth whole scorecard.